In today's lesson, we're going to be talking about box and whisker plots. In 6th grade, one of your goals is to display numerical data in plots on a number line, including dot plots, histograms, and box plots. Today, we will be talking about box plots. The table shows the highest drop of 11 roller coasters. Create a box plot of the data. So here we have a list of different roller coasters and their drop in feet. King Dakar, Top Thrill Dragster, Steel Dragon, Millennium Force, Intimidator, Goliath, Titan, Fujiyama, Phantom's Revenge, Desperado, and Bizarro. I realize that there are two tables here, but I want you to consider them all one set of data. So this is just one set of data. And they've actually listed the data from greatest to least for us, which is very nice. This is the type of graph we're going to make. This is called a box and whisker plot. So in the end, you will have a graph that looks like this. It doesn't really look like a normal graph. This is a new type for all of us. And step 1, gather your data. Step 2, organize the data from least to greatest. Step 3, find the median of the data set. The median is also called the second quartile. Step 4, find the first and third quartiles. Now we need to find the median of the lower half of the data set as well as the upper half. So here we have the lower half, and we find the middle. Here we have the upper half, and we find the middle. This is our median. This is the median of the lower half. This is the median of the upper half. We have our first, second, and third quartile. You may be asking yourself, well, where is the fourth quartile? When we divide a loaf of bread, let's say amongst 4 people, I want 4 pieces of bread. How many cuts do I need to make? Well, if I want 4 pieces, I only have to cut 3 times. I have 1, 2, 3, 4 pieces, but I had 3 cuts. So this is quartile 1, quartile 2, and quartile 3. I considered the quartiles the cuts. So the first quartile is the first cut, the second quartile is the second cut, and the third quartile is the third cut. Step 5, draw a plot line. Step 6, mark your first, second, and third quartiles on the plot line. So I've drawn my second quartile, 255, and now I'm going to draw 228. and 306. Step 7, make a box by drawing horizontal lines connecting the quartiles. 8, mark your outliers, the minimum and the maximum. So my minimum is 221 and my maximum is 418. 9, connect your outliers to the box with a horizontal line. Now, this is a preference. I drew a line here like this. Some box plots draw the line, others don't. That's more of a design preference. You don't actually have to do that. You could just put the dots. Step 10, finished. You can erase the dotted lines below the box. So the lines right here are the whiskers. And then obviously the box is the box. The first section, the whisker on the left, is the first quartile. The first half of the box is the second quartile. The second portion of the box is the third quartile. And the whisker on the right is the fourth quartile. Now, a box and whisker plot does not have these colored sections, like a bar graph or anything like that. I've only highlighted this so that way I could discuss it with you. So this whisker is all of this is considered the first quartile. But when you do any calculations where they ask you questions about the first quartile, you're going to use this line right here, which is 228. So that would be considered quartile 1. If they ask you for quartile 3, you're going to use this line, which is 306. And if they ask you for the second quartile, you'll say 255. So even though all of these numbers or values inside the box here would be considered the second quartile, when we refer to it in a mathematical equation, we're going to use the number that is the median. And similarly, we're going to do the same thing for the other quartiles. So this line is the first quartile, this line is the second quartile, and this line is the third quartile. Each quartile represents 25% of the data because 1/4 equals 25%. If we look at the top, there are 3 roller coasters in quartile 1. There are 3 roller coasters in quartile 2. There are 3 roller coasters in quartile 3. There would be 3 roller coasters in quartile 4, but I have an uneven number. So therefore, that is why we have an uneven number here. But if it was even, it would be 3, 3, 3, and 3. So if my data is divisible by 4, then it would be perfectly even. When we have a box and whisker plot, the minimum number, in this case 221, is not really referred to as the minimum, but rather the lower extreme. And then on the other side, the maximum, in this case 418, is referred to as the upper extreme. One of the things that we can compute is the interquartile range. You know that we can compute range, which is the maximum minus the minimum. And in this case, that would be the lower extreme to the upper extreme. So that would be the range. Well, in a box and whisker plot, there's another calculation that we can figure out, and that's called interquartile range. The beautiful thing about math is that the titles of our mathematical skills tell us what to do. Inner means inside, and quartile refers to the quartiles. The first, second, third, and fourth. So which quartiles are inside our graph? Well, right here and here mark inside. So the range is from the first quartile to the third quartile. So we subtract 306, take away 228, and that gives us 78. This is the interquartile range, the third quartile minus the first quartile. Next, we can calculate outliers. The outliers are the interquartile range times 1.5. So we're going to multiply 78 times 1.5, and we get 117. Now what do we do with that number? We're going to add that to the third quartile. So here's the third quartile, and we're going to add 117 to it. Also, we're going to go to the first quartile, and we're going to subtract 117. So 306 plus 117 equals 423. Any value 423 or higher is considered an outlier. We don't have any data points that high, so we have no outliers on the upper half of our data. Taking a look at the lower portion, we will do 228 subtract 117, and we get 111. Our lowest value is 221, so we do not have any outliers in the lower half of our data. Now, let's say that we did have an outlier. How would that look? Well, if you have an outlier, basically, we don't connect outliers with the whisker. That outlier would become a point, and then the next number before it that isn't an outlier would be a dot, and the whisker would connect to that dot. Thank you for learning about box and whisker plots with me. This is Mrs. Smith signing off.